Okay, so today we're going to do function composition, Unit 2, Lesson 3 notes. You can find this on page 9 in your booklet. Since functions convert the value of an input variable into the value of an output variable, it stands to reason that this output could then be used as an input to a second function. This process is known as composition of functions. In other words, combining the action or rule of two functions. That's what we're going to take care of today. So, a circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. A says, determine the area of this garden to the nearest square foot. So some key information here that we recognize is we kind of want to know what is the area of this circular garden. So our area for a garden is A equals pi times r squared. And what they give us here in our instructions is that the radius is 15, which is the same as r. And then they tell us that the cost is $1.25 per square foot of the garden. So let's look at how we can use this to set up an equation. So our area, we don't know. However, we do want to find the area, equals pi times our radius, which in our case is 15, and then square it. So area equals pi. 15 squared gives us 225. And on a calculator, if you were to multiply 225 by pi, we would get rounded about 707 feet squared. So I also want us to recognize what our input value was. Our input is going to be the radius, and our output is the area. Part B says, using your answer from A, calculate the cost of covering the garden with topsoil. So we already know that area equals the 707 square feet times, we know that it costs $1.25 per square foot of garden space. So we know our area times $1.25, and that's going to give us, I should erase that. The right is 707 times $1.25, and that's going to give us roughly about $883.75. We're just multiplying our area times how much it costs per square foot of garden space for that topsoil. In this exercise, we see that the output of an area function is used as an input to a cost function. It's important that we recognize that. This idea can be generalized to generic functions f and g as shown in the diagram below. So input, we said, was our x value, and we said that our output value is y. We talk about output from f becomes the input to g. So what that really means, I'm going to kind of write it in a different manner, is that just means that we have a function, and then we also have another function that sits inside our original function. That's what we're really going to be looking at today. Two functions and how we can put those inside of another function to get out a different function. So we have basically input, 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 input until we get our final output. There are two notations that are used to indicate compositions of two functions. These will be introduced in the next few exercises, both with equations and graphs. So exercise 2, it tells us that given f of x equals x squared minus 5 and g of x equals 2x plus 3, Find the values for each of the following. So I want us to kind of look here. We're going to look at this inside part here first that says g of 1. I know it says f on the outside, but let's look at g of 1. My g of x function is here. Ultimately, what I'm going to do is I'm going to have g of 1 equals, and everywhere I see an x value for my g function, I'm going to plug in 1. So I have 2 times 1 plus 3. I'm going to simplify that. So 2 times 1 is 2, plus 3 gives me 5. So that's what g of 1 equals. Now, this value of 5, I'm going to highlight that. And I'm going to replace it with g of 1. So that means, notice how you have an f on the outside? You're going to have f of 5. So just substituting in where g of 1 is for 5 now. And so remember, I have an f function, but I'm going to plug in 5 everywhere I see an x. So I have 5 squared minus 5. Well, I know 5 squared is 25. 25 minus 5 gives me the value of 20. So that is our final answer. Let's look at B. Again, we have this f of 2. I'm going to plug it into this f of 2 function here. And I'm going to have g. I'm not going to worry about that right now. So I'll have f of 2 equals, I'm going to plug in 2 everywhere I see an x for the f of x function. So I'll have 2 squared minus 5. And let's simplify that. 2 squared gives me 4. 4 minus 5 is negative 1. I'm going to go ahead and highlight this f of 2 and my negative 1. Because that means I'm going to substitute. But look on the outside of our B question, we start with g now. So I want g of negative 1. So I'm going to take negative 1 and plug it into my g of x function everywhere I see an x. So I have 2 times negative 1 plus 3. So 2 times negative 1 gives me negative 2 plus 3 gives me 1. So I want you to go ahead and try C on your own, and then we'll pause it and see what you get. So this was a little different. We had to take g of 0, plug that into the function of g of x, and then we got out the value of 3. Then I took 3 and plugged it into my g of 3 function again. Notice how the outside is still g. And when I plugged in 3 again to my g of x function, I get out the value of 9. All right, so let's look at D. So I know on your notes, it may be a box there. Go ahead and fill it in kind of with the circle. Kind of looks like fog for the first one. But the meaning of it is exactly the same as what we just did above. So what I'm going to do is go ahead and rewrite all of D, E, and F so it looks a little more familiar to A, B, and C. So I'm going to rewrite F open circle G as F G of X. Not even including the negative 2 yet. I'm going to rewrite this one as G F of X. Notice where I'm putting these locations. The G is always farther on the outside. The first letter is always on the outside. The second letter is always on the inside. And for F, I'm going to rewrite that as F of X. Now, if we kind of compare it to what it looked like for A, I'm going to go ahead and plug in my numbers. Might help me see a little better. So I'd have F G of negative 2, G of F of 3, and F of negative 1. I know the parentheses could be a lot for you, so let's kind of break these down. So we have F G of negative 2. We're still using the same functions. So my function value is x squared minus 5. I'm going to plug those in. So for my g of -2, I'm going to use the g of -2 function. I'm going to plug -2 in. So I'll have, for g of -2, I'm looking for plugging in -2. So I get 2 times -2 plus 3. And so when I just have to scroll this down a little bit. But now I have 2 times -2 is -4 plus 3. That gives me a -1. Then I have to now find what is f of -1. So putting -1 into the f of x function. Scroll up here and see my f of x function. Plugging it in for x for the f of x function. So I have -1 squared minus 5. So -1 squared gives me +1. 1 minus 5 gives me a -4. And that's my final solution. Go ahead and try the next two and see how you do on those. We'll come back in a minute. Did you get 11 for E and 10 for F? If you didn't get those values, I would circle those problems and we can go over them in class if you still have questions. Okay, so exercise 3. The graphs below are the functions of y equals f of x. I'm going to highlight these. Y equals f of x is this line. And g of x, y equals g of x, is this portion highlighted in blue. Evaluate each of the following questions based on these two graphs. So what I have here is the first one for A says g of f of 2. It looks like a lot going on here. So I'm going to highlight in yellow. Oops, wrong color. Definitely not yellow. Highlight in yellow the f of 2 portion. So f of 2 is really, I'm only looking at the portion that's highlighted in yellow, and I'm also only looking at the function of f of x. So if x is going to be 2, so remember that's your x value. If x is 2, I count over to 1, 1, 2, I want to know what is that y value going to be. Well, there's my y value right there. So at f of 2, that means that my y value is over 2 and it's going to be 3. So now I'm looking for g of 3, which means I now have to go to the portion that's highlighted in blue. So now I'm looking for the blue portion. So if I look for the blue portion, I go to g of 3, again, meaning 3 is our x value, 1, 2, 3, and I go up, and at this point, I'm at 3 as well. So that means g of 3 equals 3, and that is my final solution. Erase this, and let's look at the next one. So we have here g of -1. So it looks like we're going to start off with the g function first. So I'm going to highlight that in blue, because that's the function in the graph we're looking at. So at g of -1, I'm going to go to my g function and scoot over to -1. And when I go down, I'm at what point? 1, 2, 3, 4, 5. So that means that this value here, g of -1, our y value is 5. So I'm going to put parentheses around this because I also need to find the f function. So remember, we're looking for f of 5. I'm going to highlight that in yellow because I'm only looking at the yellow function, which is f of x. So if that's the case, I'm looking for +5 when f was -1. So let's count over x is 5. 1, 2, 3, 4, 5. And I'm going to go up, and it's kind of right about there. So I'm going to say that's about 1, 2, 3, 4, about 4.5. So at 4.5 is when f is 5. Let's kind of do C together. So with C, we're starting off with only looking at the blue function. So highlighting that inside portion in blue, I want g of 1. So for g of 1, I have, let's see, 1, I'm right here. So that means at g of 1, I'm at the value of 3. Throw parentheses around it and put my g outside. I want to know, well, what is g of 3? So I'm going to count over 1, 2, 3 and go up 1, 2, 3, and I get right there. And g of 3 is also 3. So that is my answer for it. So let's scroll down to D. Notice that I don't have any circles in there, and that might be because yours has lines, or sorry, might just have boxes. I'm going to go ahead and put that open circle there. We're going to go ahead and rewrite these with the numbers in them like we did the last ones. So we have g of f of negative 2. And I have f of g of 0. And I have f of 0 for that function there. So I'm going to let you try D, E, and F and see what you get. We'll come back together. All right, so take a minute. 3, 2, and 3 is what I got as my answers. Again, if you didn't get those answers and you really feel like you need some more explanations, go ahead and highlight those, and don't forget to ask us in class on Monday. All right, so let's look at the next one. On occasions, it is desirable to create a formula for the composition of two functions. We will see this facet of compositions throughout the course as we study functions. The next two exercises illustrate the process of finding these equations with simple linear and quadratic functions. Example 4 says, given the function f of x equals 3x minus 2 and g of x equals 5x plus 4, determine formulas in simplest y equals ax plus b form for the following. So the goal is to, I'm going to go ahead and highlight this one in purple. The goal is to get it in a form like this. Y equals ax plus b. This is where it can kind of get a little tricky, but I know we can do it. So I'm going to go ahead and highlight the first equation in yellow, and I'm going to highlight the second equation in blue. So my first step is to look at g of x for part A. I only care about g of x right now. And since that's g of x, I'm going to go ahead and rewrite it as this. F, and I'm going to plug in everything that's g of x. So that 5x plus 4 is my entire g of x function. Notice how we don't have values for x. It's a little different. Now, I'm going to erase this portion here. And my goal now is to find out what is the entire thing of fg of x. So now my input value is the entire 5x plus 4, which is kind of large, but it'll work. So we're going to plug in 5x plus 4 everywhere we see an x in our f of x function. So we'll have 3 times 5x plus 4. And then don't forget that minus 2 on the outside. Sometimes we forget that we subtract something. So now I'm going to distribute so I can simplify it and get it what's in purple down here. So I have 15x plus 12 minus 2. Notice how I got rid of those parentheses. I have some like terms here I can combine. 12 and minus 2. So that gives me 15x plus 10. Now that's in the form that's purple. We have ax plus b, which gives us 15x plus 10. All right, let's try b. So again, we're going to mark through this. We have f of x first. So notice how we're going to start off in yellow. So f of x is what we're using to substitute into g of x. So again, I'm going to go ahead and bring my g down. And everything that's the f of x function, I'm going to just plug it in. So 3x minus 2. And now I'm looking for the entire function of g of f of x, which is all of this below. So everywhere I see a x in my g function, I'm going to plug in 3x minus 2. So I'll have 5 times 3x minus 2, and don't forget that 4 on the outside, plus 4. Again, we need to simplify so we can get it to look like the purple. Distributive property. We have 15x minus 10 plus 4. Let's combine these like terms. We'll get 15x minus 6. And that's our final simplified expression. All right, the last part is exercise 5. Whew, I know we made it. Still got some time here. If f of x equals x squared and g of x equals x minus 5, then f times g of x is what? So I'm going to go ahead again. I like to highlight everything. So my yellow function is f of x, and my g of x function is in blue. I'm looking for first the g of x function. So I'm going to rewrite it like we did above, and I'm going to write it as f. My g of x function is this x minus 5. I'm going to plug that in. Then I'm going to take my x minus 5 and plug it in for x for the f of x function. So I'll get x minus 5 squared. So just substitute it in for x. Well, this kind of brings back some of our box method in foiling. So I'm going to rewrite it as x minus 5 times x minus 5. So for my box method people, here we go. X and minus 5 and x and minus 5. My foiling folks, let's do this together. So we got x times x, which gives us x squared. X times x gives me x squared. X times negative 5 gives me a negative 5x. And x times negative 5 gives me a negative 5x. Negative 5 times x gives me a negative 5x. And negative 5x times negative 5 times x gives me a negative 5x in my box. Last part, negative 5 times negative 5 gives me a positive 25. And negative 5 times negative 5 gives me 25. For my box people, we're going to combine these things that are circled. My foiling folks, we're going to go ahead and combine our like terms in the middle. We get x squared minus 10x plus 25. And you should get the same for my box method people. So whichever method that you do, you choose what's best for you. So that means our answer should be 4. All right, so make sure you start everything that you have problems with, and make sure you ask your teachers first thing on Monday. See you guys. Have a great weekend.